Hello everyone, welcome you all. In this video, we will discuss the MCQs from Quark Hypothesis. All the selected and important questions have been taken, which will be very much helpful in your upcoming exam. Okay, let's start. Question. The strangeness quantum number is conserved in. We know the strangeness quantum number is conserved in strong and electromagnetic interaction, and this is not conserved in weak interaction. Okay, so your correct option is option C. Similarly, you should remember for other, like for strong electromagnetic weak, like isospin is conserved in strong but not conserved in electromagnetic and also not conserved in weak interaction. Isospin third component conserved in strong interaction, conserved in electromagnetic interaction but not conserved in weak interactions. Next, Parity conserved in strong, conserved in electromagnetic, but not conserved in weak interaction. Okay, next. Weak nuclear force acts on weak nuclear force that acts on all particles. Okay, so your correct option is option D. Next, a stationary particle in free space is observed to spontaneously decay into two photons. This implies that, okay, so any particle X decays into two photons. Okay, so now you can check the options. Particle carries electric charge. Spin of the particle must be greater than or equal to 2. The particle is a boson. The mass of the particle must be greater than or equal to the mass of the hydrogen atom. Here you can check the spin. As this is a nuclear reaction, so it will be allowed only when the spin in both side will be conserved. Okay, so here spin of photon is 1. So total spin in the right hand side is 2. So in the left hand side, spin should be 2. Okay, and as it is a integer, so the particle must be a boson. Okay, so the particle is a boson. So your correct option is option C. Next, the nucleus of the atom beryllium consists of, this should be like this, for beryllium 9. Okay, so here you can see Z is 4 and neutron number is 5. Okay, that means there are 4 protons and 5 neutrons. And we know one proton consists of 2 up quark and 1 down quark. That means 4 protons will consist of 8 up quarks and 4 down quarks. Next, there are 5 neutrons and 1 neutron is made up of 1 u quark and 2 down quark. That means there will be 5 u up quarks and 10 down quarks. So there will be total of 13 up quarks and 14 down quarks. Okay. So 13 up quarks and 14 down quarks. So your correct option is option B. Next, by capturing an electron, manganese transforms into chromium, releasing. Okay, so write down manganese 25 plus electron minus 1. This is minus 1. Chromium 24 plus. So you have to find this particle. Okay, so you can check the lepton number here. Charge is conserved. Okay, so 25 minus 1, 24. Charge is conserved. So you have to check the lepton number. Here, lepton number in left hand side is plus 1. So right hand side, lepton number should be plus 1. So here from option you can see a neutrino. A neutrino will give you lepton number plus 1. Okay, so your correct question is option A. A massive particle X in free space decays spontaneously into two photons. Which of the following statements is true for X? So we have discussed already this question. So this is your boson. Okay, correct option is option C. Okay, next. See, there are some questions from GATE exam. GATE exam. So see, this is the first question. The isospin and strangeness of omega baryon are. we know there are no multiple of omega baryon, so the isospin will be 0. And for strangeness, we know omega boron has the quark combination of S S S, and for 1s there will be -1 strange numbers, so there will be total of -3. Okay, so isospin 0 and strange numbers -3. So your correct option is option B. Next, match the reactions on the left with the associated interactions on the right. Okay, so you have to match these three reactions with this strong electromagnetic or weak. Okay, so you can check with the conservation laws, or you can remember some important points, like if there is involvement of photon in a reaction, then most probable is that that reaction will be electromagnetic. Okay, so this two will be electromagnetic, and if there is a neutrino, most probability that the reaction will be weak. Okay, so one weak. Then third one, if there is mesons, okay, or pions, then this will be strong reaction. Okay, so you can check here option 1, 3, 2, 2, and 3, 1. So this is your correct option, option A. The decay process violates baryon number. You can check baryon number 1, 1, 0, 0. Baryon number is conserved. Then lepton number also, lepton number 0, 0, plus 1, minus 1. Baryon number, lepton number is also conserved. Then isospin. Isospin, third component, you can check this neutrino H minus half, proton H plus half, 0, 0. Okay, and strangeness is 0, 0, 0, 0. So this isospin third component is not conserved. Okay, so here your correct option will be option C. This is a question from GATE exam. Next, which of the following statements is not correct? A deuteron can be disintegrated by irradiating it with gamma rays of energy 4 mega electron. This is correct because we know the binding energy of deuterium is approximately 2.22 mega electron volt. Okay. A deuterium has no excited state. This is also correct. A deuterium has no electric quadrupole moment. This is not correct because see we know the deuterium has some finite and positive quadrupole moment, and this is approximately 0.28 femtometers square. Okay, so this is your correct option. This statement is not correct. Okay, the 1s0 state of the deuterium cannot be formed. This is correct. Next, which one of the following is a fermions? Okay, so for fermion, we know the spin will be half integer. Okay, so you can check. So for half integer spin, there should be odd number of nucleons. Nucleons. So you can check this beryllium having odd number of total number of nucleons. So this is correct option is option B. In SU3 quark model, the triplet of mesons has, you can see, you can calculate the isospin. We know M equals to 2i plus 1. So from here, I equals to m minus 1 by 2. Multiplicity is 3. So 3 minus 1 by 2 is 1. So isospin is 1. Okay. And strangeness for pions, we know 0. Okay. So your correct option is option B. Electromagnetic interactions are, okay, we know in electromagnetic interaction, C conjure, Cp conjure, CPT. CPT in all reactions this is conjugate. Okay, CPT conjure, parity conjure. Okay, and T also conjugate in electromagnetic interaction. So from option you can check This option A is your correct option. C conjure. Next, which one of the following conservation laws is violated in the decay of tau? Okay. So here tau plus gives rise to one plus one plus one. Okay. So here you can check from the option. If you check the total lepton number for tau plus, this is antiparticle of tau. So you can write this to be minus one, minus one, minus one. This is plus one. Okay. So total lepton number is conserved. This is conserved. But if you check this tau number, okay, tau number here in this side it is minus one, and in right hand side this is 0, 0, 0. So in this reaction, this tau number is not conserved. So this violates the tau number. So your correct option is option D. Next, consider the reaction manganese plus electron gives rise to chromium plus X. So again here you can check the lepton number. Left hand side this is plus one. Okay, so right hand side you need a particle with lepton number plus one. So that will be your neutron. Okay, which will give you plus one lepton number. So your correct option is option B. The decay 1 plus gives rise to positron plus photon is forbidden because it violates. Again you check here the lepton number, like in the left hand side one number is minus 1, here 0, 0. Total lepton number is conserved here, but if you see the separate lepton number is not conserved. Okay, so this violates the lepton number conservation. The decay process violates isospin. Okay, so your correct option is option C. The isospin and baryon number of half quark. We know a baryon like proton consists of three quarks, like proton consists of U, U, D. So a quark having baryon number 1 by 3, and isospin for half quark is half. Isospin is half. So correct option will be option D. The charm quark S assign a charm quantum number C equals to 1. How should the Kalimann-Nishijima formula for electric charge be modified for four flavors of quarks? Okay, so we know Q equals to I3 plus half B plus S plus C. Okay, so option D is your correct option. A particle with a composite state of three quarks U, D, and S has electric charge, spin, and strangeness respectively. Okay, so for U, D, and S, we know for charge for up quark is plus 2 by 3, for down quark it is minus 1 by 3, and for strange quark also it is minus 1 by 3. So here you can see the total charge will be 0. Next, spin for up quark is half, down quark half, and also for strange quark it is half. So spin will be half or 3 by 2. Okay. Next, strangeness. Strangeness is 0, 0, minus 1. So this will be minus 1. So you can check the options like 0, half, and minus 1. 0, half, and minus 1. So C is your correct option. Baryon decays by strong interaction. H this. So here sigma plus is a member of the isotriplet, the third component of the isospin of X. So okay, you can check from the reaction directly. The third component of isospin. Okay, right hand side you can see For sigma plus, it is plus 1. For pi minus, this is minus 1. And for pi 0, this is 0. So in right hand side, total isospin third component is 0. So in left hand side, it should be 0. Okay. So A is your correct answer. A particle X is produced in the process via the strong interaction. If the quark content of the K plus is U S bar, the quark content of X is. Okay, see, it is given that this is a strong interaction. That means the strangeness quantum number should be conjugate. Okay, and you can see in the left hand side there is no strange quantum number. So this is 0. And if right hand side, if you see this K plus is having a quark combination of U S bar. That means for K plus, strangeness quantum number is plus 1. So this X will be having the combination of quark such that the strangeness quantum numbers will be minus 1. So that the total strangeness quantum number will be 0. So from option you can check only option C is satisfied. That is UUS. Because from here, S will give you the strangeness quantum number of minus 1. Okay. So your correct option is option C. Next, a particle Y undergoes strong decay. The isospin of Y. Okay, this is strong. So isospin will be conjugate. Okay, so for pi minus, we know isospin is 1, 1. So for Y, isospin will be 2. Okay, next, consider this reaction. So here, correct option is option B. Next, in the nuclear reaction, the particle X is, okay, again here you can check here the charge and lepton number. Okay, so here your correct option is option A, electron. Among electric field, magnetic field, angular momentum, and vector potential, which is are odd under parity? Space inversion of S. We know electric field and vector potential A are odd under parity. Okay, and magnetic field and angular momentum are even under parity. Okay. So your correct option is option B. In the SU3 quark model, the triplet of mesons has isospin 1 and strangeness number 0. Isospin 1 and strangeness 0. So your correct option is option B. The decay process violates isospin. Here again, this question's correct option is option D, lepton number conservation. Next, the quark content of sigma plus, K minus, and pi minus and proton is indicated in the process considering the strong interaction only. Which of the following is true? Okay, see, this is strong interaction. So strangeness will be conjugate, isospin will be conjugate, and isospin's third component will be conjugate. So here you can check. So starting with strangeness number. Okay, so here you can check for pi minus, this is strangeness number is 0. For proton, it is 0. Then now right hand side for K minus, it is minus 1. And for sigma plus, this is minus 1. Okay, so in left hand side it is 0, and right hand side it is minus 2. So strangeness number is not conjugate. Strangeness number is not conjugate. Okay, so this process is not allowed. You can again check for the isospin third component, that will not be also conjugate here. Next, which of the following reaction violates lepton number conservation? Lepton number. You can check option A, positron, that is minus 1, plus 1, plus 1, minus 1. So here lepton number is conserved. Option B, plus 1, plus 1. Here also it is conserved. Option C, this is minus 1 positron. So right hand side, this is plus 1. So here in option C, lepton number is not conserved. So this is your correct option. Option C. Next. Parity is conserved in strong and electromagnetic interactions. Remember, parity is not conserved in weak interactions. Only conserved in strong and electromagnetic interactions. Heaviest among U, D, and S quarks. Okay, S quark is heaviest among these three up, down, and strange quarks. Okay, this U and D having approximately same mass around 0.39 mega electron volt, and for S quark it is around 0.5 mega electron volt. Okay, approximately. So this S quark is heaviest. Next, weak interaction has a lifetime of 10 to the power minus 10 second. Okay. Similarly, for strong and electromagnetic, you should remember for strong, this is 10 to the power minus 23 second approximately. Okay. Of this order. Then for electromagnetic, it is 10 to the power minus 20 second. Then this is for weak, and 10 to the power 16 second is for rapid. Next, strange particle decays through. Strange particle decays through weak interaction. They produced through strong interaction, but they decay through weak interaction. Okay, so your correct option is option B. Neutrino left-handed helicity, but for anti-neutrino, right-hand helicity. Okay, anti-neutrino. Next, spin of photon is 1. Spin of graviton is 2. Okay, so your correct option is option D. Hypercharge. Hypercharge. Okay, we have the expression of Q equals to I3 plus B plus S by 2. Okay, so here we define the hypercharge. Okay, I am leaving this question for you. Okay, you write down the correct option in the comment section. Okay, spin of neutrino is half. So your correct option is option B. Again, spin of electron neutrino is half. Then spin of omega is 3 by 2 omega baryon. Okay, so parity you remember 3 by 2 loss for omega baryon. Hypercharge of U quark, up quark. See, hypercharge is defined by Y equals to B plus S. Up quark has a baryon number of 1 by 3 and strangeness 0. So hypercharge will be 1 by 3. So your correct option is option D. A baryon is made up of 3 quarks. Okay, like you can see proton UUD, neutrino UDD. Next, charm and top quarks have charge of, okay, UDS CBT. So charge of charm and top quark. This is plus 2 by 3e plus 2 by 3e. But for bottom, you remember this is minus 1 by 3. Similarly, here for up quark, it is plus 2 by 3e. For down quark, it is minus 1 by 3. For strange quark, it is minus 1 by 3. So for charm and top, plus 2 by 3 plus 2 by 3e. So this is your correct option. Option D. Bottom quark has a charge of bottom quark minus 1 by 3e. First generations quarks are U and D. Okay. Similarly, you should remember first generation leptons are electron and electron neutron. Similarly, second generation quark, second generation. This is your charm and strange quark. And second generation leptons, muons and muon neutron. Third generation quark, top and bottom, third generation, and third generation lepton, tau 1 and tau 1 electron, tau 1 neutrino. A meson is made up of quark and antiquark. So D is your correct option. Homogeneity of space leads to conservation of linear momentum. This is very important. Next, homogeneity of time leads to conservation of energy. Isotropy of space leads to conservation of angular momentum. So C is your correct option. Eigenvalues of parity operator are plus minus 1. Okay, so A is your correct option. So this is P square equals to 1. Next, gauge invariance of electromagnetic field leads to conservation of charge. Next, multiplicity of delta baryon is 4. Okay, we know there is delta plus plus, delta plus, delta 0 and delta minus. Okay, so you write the quark combination of all these 4 delta baryons in comment section. Okay, so let's stop here. I think this will definitely help you in your exam preparation. And if you like this video, don't forget to like, share and subscribe to our channel. Thanks for watching. See you in the next one.